Bowman.
And I'm Krithik.
And we are the Math Men. And over the next few months, we're going to make some useful
And some not so useful
mathematics videos that will hopefully be interesting as well. Now today we're going to be talking about matrices. Really, it's just an arbitrary designation of numbers in brackets like this. Now this is a 2 by 2 matrix, 2 columns and 2 rows. The cool things about matrices is they can be used to model some difficult equations, such as the wave function for chemistry and other mathematical modeling purposes. So let's talk about some of the really basic functions we can do with matrices. And let's start with what I think is the easiest one, which is addition. The easiest thing about addition is that when you're adding two matrices, you can only add matrices that have the same number of rows and the same number of columns. So if we have two matrices that we want to add, all we do is we add matrices that are in the same position on the grid. So 4 and 7, and then we've got 3 and 5, 2 and 6, and 4 and 1. And we have a new matrix with the same number of rows and the same number of columns. Subtraction is just as easy as addition. You have to have a matrix with the same number of columns and the same number of rows as the matrix that you are subtracting from it. So, that's a 4. If we have our original matrix and want to subtract something from it, then we're just going to subtract the matrix with the number in the same grid location as the one you're subtracting from it. So this is going to yield a matrix like this. That's a -2, I promise. Now, multiplying matrices is a little bit trickier. If we multiply a matrix by just one number, it's pretty simple. That one number is called a scalar. That is a multiplication symbol, I promise. And all you do with the scalar is you multiply each grid point in the matrix to come up with your new matrix. However, if we're multiplying a matrix by another matrix, we have a special caveat. Now, this matrix has 2 rows, so whatever matrix we multiply it by has to have 2 columns. And because this matrix has 3 rows, this one must have 3 columns. Now, when we multiply a matrix, we're going to end up with an answer that have the same number of rows as the first multiplier and the same number of columns as the second multiplier. So, how do we get those columns and rows? Our final matrix will have its first grid box filled in with the first row multiplied by the first column and added together. So, this spot right here is going to be 3 times 3, 1 times 7, and 4 times 4. So, 9 plus 7 plus 16 will give us the spot in our first block. Then, we're going to take 3, 1, 4 and multiply it by our second column in the other spot to get the next block in the top right. 3 times 9, 1 times 8, and 4 times 1. Really hope I'm not adding these incorrectly. Then, we'll take our second row and multiply it by our first column. So we're going to take 2 times 3, 0 times 7, and 5 times 4. And finally, we'll take the bottom row times the right column and add those together. 2 times 9, 8 times 0, and 1 times 5, 23. So the matrix of 3, 1, 4, 2, 0, 5 multiplied by the matrix of 3, 9, 7, 8, 4, 1 yields the matrix 32, 39, 26, and 23. When we divide matrices, all we actually do is multiply our first matrix by the transposed second matrix. So if we were going to take this matrix and divide it by this matrix, we would take and multiply this matrix by this transposed. The T in the upper right means to transpose the matrix. And all you do is you take this matrix and put it in the same spot, and then you flip columns and rows. So this column, 3, 4, becomes the new row, and then this column, 7, 9, becomes the new row. So our 3, 7, 4, 9 becomes 3, 4, 7, 9. I'm going to go ahead and do another one of these with a 3 by 2 matrix. And transpose that one so that we can see this becomes 3, 7, 5, and 9, 6, 4.
The determinant is a special number that can be calculated from a matrix. It tells us things about the matrix that are useful in solving a system of equations or other properties of calculus. So we'll first figure out how to find a matrix of a 2 by 2. So to find the determinant of this 2 by 2 matrix, we'll first multiply the number in the top left corner, the 2, by the number in the bottom right corner, the 4. And then we will subtract that quantity from the number in the top right corner times the number in the bottom left. So this gives us 8 minus 6, or 2, which is the determinant of the matrix. So in short, to find the determinant of a 2 by 2 matrix, start with the number in the top left and multiply it by the number in the bottom right. Then multiply the number in the top left by the number in the bottom top right. I know my directions. With the number in the bottom left, forming a kind of X pattern. And solving that will give you the determinant of a 2 by 2 matrix. Three by 3 matrices are a bit of a hassle. To find the determinant of a 3 by 3 matrix, such as this matrix, the best way to explain this is to use an example. So to find the determinant of this matrix, we will first take the number in the top left corner, 1, and multiply it by the quantity of the determinant of this submatrix here, 1, 2, 2, 1. So recalling how to find the determinant of a 2 by 2 matrix, using that same procedure, we can plug in 1 times 1 minus 2 times 2. But that's just the first part. Then we need to subtract the first number in the second row, 2, times this 2 times 1 minus 2 times 1. So we've essentially created another submatrix using these 4 terms. And the third final step to find the determinant of this matrix is to add the first term in the last column, 1, times 2 times 2, that's 4. 2 times 2 is 4, just for the record. And then subtract that from 1 times 1. So this is the final submatrix here, using these 4 terms. Then if we solve this expression, we get -3 minus 0 plus 3, which gives a total of 0. Finding the properties of matrices can be quite a hassle when doing them by hand. But luckily, we have technology today that can help us find the sums, differences, and even the determinants of complex matrices. So we'll first look at how to input a matrix into a calculator. First, open the matrix menu. This can be accessed by pushing the second button and then the x to the -1 key, which has the word matrix in blue above it. This opens up the matrix menu. So you can input up to 10 different matrices into your calculator. To input a matrix, move over to the Edit column. Then select the matrix you want to edit. At the top right, you can see the dimensions of the matrix. And so for this example, we'll use a 2x3 matrix. If we click Enter, the rows and columns of the matrix appear below. Then we can input any of the numbers we wish. Then if we go back to the main screen, we can recall a matrix by moving back to the matrix menu by pushing the second key, then x to the -1, and we see that the stored matrix is stored as matrix A. If we click Enter and enter again, we can recall the digits that we entered into the matrix. Now for adding matrices. If we go back to the matrix menu and add one more matrix as matrix B with the same dimensions with just different digits, we can add both of these matrices together. To do this, go back to the matrix menu, select both of the matrices, matrix A plus matrix B. Because the dimensions are the same, we can add them without getting an error message. So when clicking Enter, we see the resultant sum of the two matrices. The same operation can be done with subtracting. Now for multiplying matrices, we simply use a multiplication key. But because the dimensions of the two matrices were the same, I got a dimension mismatch error. To fix this, simply quit, go back to the matrix menu, and edit the matrix to have a 3x2 dimension instead of a 2x3. Then if we go back and multiply the two matrices, we get the resultant product. The same can be done with division. However, when dividing, we have to again go back to the matrix menu and recall that when dividing matrices, we multiply by the transpose, which can be found in the math menu on number 2. So to divide two matrices, we'll first go to the matrix menu and make sure that each matrix has the same dimensions. Then if we go back to the main screen and open up matrix A, multiply it by matrix B, and then add the transpose symbol to matrix B, we get the resultant matrix of dividing matrix A by matrix B. The determinant of a matrix can also be easily found by using the calculator. To do this, open up the matrix menu and make a new matrix of the same dimensions, let's say a 3x3, and enter the values required. Then go back to the main menu, and in the matrix menu, select the matrix you want to find the determinant of. Then, in the math column, under number 1, is DET. This stands for the determinant. If we input the determinant of C, it gives us the result as -93. Now because doing this by hand is quite tedious, using the calculator to find the determinant of complex matrices can be a great gift.
Well, that's the extent of our knowledge on matrices. And we hope you enjoyed it, and we hope you learned a lot.
About matrices.
Right. So, if you tune in for Krithik's video about constructions, you'll learn something. And if you tune into my video about probability, you might be able to go win something at the casino. Until then, keep on learning, and have a great time.
So going to the matrix menu, under the math column, and selecting the T, we still get a dimension mismatch error. Crap. Bottom right-hand corner. So 2 times 4. Then multiply... No, don't multiply.
Am I stopping this one? Okay, I'm Bowman.
And I'm Krithik.
And we are the Math Men. And over the next few months, we're going to make some useful...
Dang it.
What?
I forgot what to say.
At the bottom of this matrices page, it explains rows and columns. The bottom. Alright, have you already started recording? Can we stop recording?
No.
Are you sure? Alright. All of this will go in the YouTube video.